Okay guys, so now we're talking about fractions and we really focused on fractional parts of objects up until this point, but I kept mentioning that fractions can also be part of a group or a set. Okay, and this can be a really simple thing, or it can be a little bit more challenging, which you'll see in a few minutes. Okay, for instance, if you look at the picture here, I have these stars right in front of me. Okay, and when we're talking about a fractional part of a group, there's a group of stars, there's 5 of them, that represents the whole group. In my one whole group, there are 5 stars, okay? That's basically like having my whole pie or my whole candy bar, right? Except now we're talking about a group being the whole. So there are 5 stars. And this can be really easy when we're talking about fractional parts of a set where something is really obvious or very easy to see. For instance, with these stars, it's very easy to see that 2 of these stars are red and 3 of them are white. So if I was going to ask you what is the fraction of this group, well, the first thing you need to know is what is the denominator. And there are 5 stars, so that makes up our denominator. In other words, there are 5 pieces to that whole group. Okay? And then I might ask you, well, how many stars are white? And you just count how many are white, and that's 3/5, right? Or 3 out of 5 are white. Or I might say, well, how many are red? And then you count the red ones, and it's 2 out of 5 stars, or 2/5 are red. So that's pretty easy. You can really see that, visualize it. You probably pick it up pretty quick. You know, if we look at the rest of these down here, a little bit here, I have these triangles, and it says 3/4. Well, 3 out of 4, or 3/4 of those triangles are blue, while 1/4 is white. I look next to that, I have a group of circles. Maybe those are baseballs or whatever they could be, okay? And 1/6 is purple. That leaves me with 5/6 being white. So that's kind of the easy part when you're talking about fractional sets of a group. When you can see the obvious difference in that group, like the color is different or the size, or for instance, if we had a group of boys and girls and we wanted to say what fraction of them are girls versus boys. Those are the obvious things that you can see in some groups. Okay? But what if here's just a few more examples real quick. Like number 1, I have a bunch of green triangles, and I can say, well, what is the fraction of the triangles that are red? And you would say 1 out of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1/10 is red. I could ask you some other questions, like, for instance, on number 1, what fraction of the triangles is pointing up? And then, of course, you would have to let me get my little thing back up here. You would have to count the ones that are pointing up, which is not quite as easy to look at, a little bit more challenging than just looking at the different colors. But you can count 1, 2, 3, 4 of them are pointing up, so 4/10 are pointing up. Then I could ask all sorts of questions, you know, how many are pointing to the left and to the right. But they're showing like obvious differences. And so you can see them and easily find the fractional part by counting the whole group, how many's in there, and then talking about whatever we're talking about, the color, pointing to the left, the shape, whatever it might be. But the harder part comes when we start talking about fractional parts of a set where nothing is different. They're all the same object, but there still is a fractional part of that set that we want to talk about. And I'm going to give you some examples in these word problems. For instance, if you look at this one, it says, Mr. G had 14 pieces of candy. He ate half of the candy. How many pieces of candy did Mr. G eat? I'm not asking for, did he eat the red ones or did he eat the ones that were chocolate or anything like that. They're all the same piece of candy represented by this blue wrapper over here. We have 14 pieces, so if I bring them out there, 3, 4, 5, 6, 7, 8. So this one might be pretty obvious to you guys, because if you think about, well, what is 1/2 of 14, you might already know the answer to this one. But the next few are going to be a little bit more challenging, but I'll show you a couple of tricks you can do to solve them real easy. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So here's 14 pieces of candy, and like I said, there's no obvious thing about these. Don't count this one over here. That's just my template. There's no obvious thing about this other than Mr. G ate 1/2 of those pieces of candy. So really simply, I just have to put these into 2 equal groups, because that is what 1/2 is. So there's 1, 2, 3, there's 4, 5, 6, 7, and then that leaves another 7 on this side. So you can see that if I ate 1/2 of this candy right here, I would have eaten 7 pieces, and 7 pieces would be left. That's 1/2. Think about the circle, right? If I cut a circle in half, how many pieces do I have? I have 2 pieces. If I cut a total amount of objects in half, how many groups would I have? Well, I have 2 equal groups. Just like the circle has 2 equal pieces, my groups would be put into 2 equal groups. This is where understanding fractions like division comes in really handy, especially when we get into harder problems, when we want to find fractional sets of a whole group, like the next couple. Okay? Take a look at these. Alright, so here Pedro has 9 marbles. He gave 1/3 of the marbles away to Lizzie. How many marbles did he give away? How many marbles did he have left? Here's where I'm going to show you a couple of tricks what you can do. We know that the denominator tells us how many parts we are going to have, right? Well, when we're talking about a fractional set of something like these marbles, that denominator represents parts, or the equal groups that these marbles in this case are going to be broken into. So there should be 3 equal groups. So what I can do for one quick strategy is draw a rectangle, or something that looks kind of like a rectangle, break it up into 3 equal groups like a fraction would kind of look like, right? So I have 3 equal groups like my fraction shows me, and then I can distribute those marbles evenly, divide them evenly, just like division, into my 3 groups until I use up all 9 marbles. Okay? So here we go. I put all the marbles in a group. I've got all the way to 9. There are now 9 marbles in the group. Well, remember, the numerator tells us about the part that we're talking about. So he gave 1/3 of the marbles away. In other words, he gave 1 group out of the 3 groups away. So let's cross this out. This is the group he gave away right here. Okay? So how many marbles did he have left? Well, he had 2/3 left. Or he had 6 marbles left. Okay? Here are the 2/3. This is 1/3 of the marbles. This is the other third. This is 1/3. And this is 1/3 of the marbles broken up into 3 equal groups. Okay? So if he gives this group away, this is the 2 he has left, and you can just count them. 1, 2, 3, 4, 5, 6. So how many marbles does he have left? He has 6 marbles left. Here's another example. Grayson is baking a cake for his mommy. He has a dozen eggs. Remember, in a dozen, that is 12 eggs. Okay? In 1 dozen, that is 12 eggs. For the cake he needs to use 2/3 of those eggs. So he needs to use 2/3 of 12. how many eggs did Grayson use? How many eggs does he have left? So again, this is what I could do. Again, the denominator tells me how many equal groups I'm breaking my set or my group into in order to know what the fractional parts are, right? So I can break that into 3 groups like we did with the marbles, and I can start putting eggs in each group until I use all 12, right? So 1, 2, 3, and I keep dividing this into my 3 groups until I use up all 12 eggs, and then I can figure out and answer the question. This is how I can solve this problem with drawing pictures. And the computer's acting a little slow right now. Not sure why. All right. And you can see that if I divide this into 3 groups, I'm going to have 4 eggs in each group. So 1/3 of these eggs would be 4 eggs, because that's how much is in one group out of 3 groups when I divide the 12 eggs into 3 groups. Okay? And the question says how many eggs did he have left? Well, if he uses 2/3, cross out 1/3, cross out 2/3. Okay, how many eggs did he use? Well, if he used 2/3, those are the 2 groups I crossed out, so he used 8. How many does he have left? Well, he has 4 left. Let me show you how you can use division to figure this out without drawing all these pictures. Well, I know that I have 12 eggs. Okay, and I wanted to find 2/3 of the eggs. My first step is to take the amount of eggs I have, or the amount of objects I have in my whole group, and divide it by my denominator, which was 3. When I do that, I come up with the number 4. That's going to tell me how many eggs I will have in each group. As you can see from the picture, it proves it. When I take 12 eggs, I divide it into 3 by my denominator. My denominator was 3. It tells me I'm going to have 4 groups. Okay? Now, my numerator, remember the top number, tells me how many groups I am talking about. In this case, that's how many groups I am using. So if I take my answer, 4, and I multiply it by the numerator, which is 2, then I know that 8 eggs is 2/3 of 12 eggs. And then the last third remaining is 4. Okay? I know this is a lot of information right here, but we will definitely practice this in class. Okay? We will go over both strategies again. And you can see how here's how it kind of looks as a fraction. I want to find 2/3 of 12. So I take 12, okay, I divide it by 3. So we're knowing your division and multiplication facts. I get my answer, which is 4. That's going to tell me what's in one group. And then I multiply it by the numerator to figure out what my fraction of those eggs would be. We'll go over this, both strategies on how to solve this. But just remember that a fractional part of a set like this is not just talking about something that is obvious, like the color or the shape of something. These eggs are all the same, but we're using a certain amount of them, a fractional part of the whole group.